quick recap on integration. So we've looked at the rule for integrating a polynomial sort of function. You add 1 to the power and you divide by the new power. You need to add a constant as well, because we know when we differentiate, we multiply by the power, we reduce the power by 1, and then any constant disappears. So this could be anything. We understand that this is true just for any n not equal to -1, because if you get -1, you end up dividing by 0, so you get a different result in that case, which we've not yet spoken about. We did some examples on that, and then we looked at applying integration. If you are given the derivative and you're given a coordinate, you can work out the function itself. We even roughly applied it to some mathematical modeling. Then moved on to seeing that integration is really powerful. We can calculate the area under a curve. Definite integration, this is called, whereas the other one was called indefinite integration. Here we talked about why it calculates the area, and then we looked at the notation, which I've not actually written down, but we use the integral sign, and then we put numbers in to say what we're integrating between, and then we're integrating with respect to x. We did talk a little bit about how this is sort of like a summation, where actually we've got a curve and we're actually adding up an infinite number of infinitesimal rectangles with width dx. So if your curve is f of x, then yeah, the height of the rectangle would be f of x, and that's what we're doing. We are multiplying the function by this infinitesimal width, and we're summing them up between, say, 2 and 4. So be aware of that. And technically, it's a limit, as this width is becoming infinitesimal. Okay. After that, we looked at what if you had a curve and it goes underneath the axis? Then this will be a positive area. This will be a negative area as such. If you wanted to work out the actual area of this curve, then you need to take that into account. You couldn't just integrate between this lower limit and the upper limit, because the negative would just be cancelling somewhat with the positive. So you'd have to find them both separately, make this one positive, and add it on. So that's something to just be aware of with integration, to be really careful. We looked at some properties of integrals. So you can integrate between, if you want to integrate between A and C, you can go between A and B, and then B to C. That can prove useful. And also the fact that you can swap them around if you put a negative in there. I think I proved this one, and I set this one as an exercise to prove. Okay, today we're going to look at calculating the area between curves using integration. So we know if we have a curve, we can use definite integration to find the area underneath it. That's not quite what we've got here, because here I've got this parabola, and then I've got a straight line, and I'm actually interested in the area between it. But we can just use our knowledge of calculating areas under curves to allow us to calculate areas between curves. So I'm going to draw a straight line going down to the axis. Actually, the first thing I want you to do is have a go at this question yourself. So pause the video and see if you can get there. Alright, so the actual answer to this problem is 96. So well done if you got that. I'm going to talk about two methods for how to get that. So first method is to recognize that I've got a triangle here that I'm shading in black, and the height is 144, because we can see that it's gone through the origin, and it tells us it's gone through 444. So that means the base is going to be 4. So the area of the triangle, I'm going to call it A1. It's going to be a half times base, half times base times height. It's going to be 2 times 144. It's going to be 288. That's going to be the whole of the black region. Okay, so to get the pink region, I could get this if I could work out this green area, and then I could subtract. I could take the black area and subtract the green area. But this green area, which I'm going to call A2, is just the integral of my 9x squared between 0 and this upper limit of 4. So I can work that out. I can add 1 to the power, and divide by the new power, so it's going to give me 3x cubed. I can put my square brackets around there, put 4 and 0 in there. Okay, 4 cubed is 64, times it by 3 is 192, and then when I minus a 0, that's not going to do anything. So I'm there basically. My final answer is going to be, so my area is going to be A1 minus A2 equals 288 minus 192, which gives me this 96 that I mentioned before. Okay, in this case it happened to be a nice triangle, and I could just work that out. What if it was some other curve? But it's going to work in the same way. I'm going to do this example again using the equation of the curve. So in this case, it's a straight line. It's going through 0. It goes from 4 to 140. Sorry, it goes from 0, 0 to 4, 1, 4, 4. So I can work out rise over run, and I can actually write down the equation of the curve. So this straight line is going to be y equals 36x. And then if I wanted to work out a1 in a different way, then it would be the integral from 0 to 4 of 36x. And then we can work that out, and again we would get 288. Now something just to be aware of, like I would treat it carefully, but just be aware that we could work out the area by doing this. We could do this, and then I could minus the integral of sorry, it was 9x squared. And then I could actually, just in the same way that when we integrate the terms separately when we're adding or subtracting, I could sort of do the opposite here and combine this into an integral. And if I work this out, I would directly get to 96. Now, it might seem I'm overcomplicating this, but it is worth knowing about this. It's like, you just, I'm showing that I understand algebraically how I could write down the whole area, as a single integral. When I integrate it, yes, I'll integrate the terms separately. I'll do my calculations. I'll get 96, but just be aware of this second way of doing it. Example 2 on integrating between curves then is as follows. Find the area enclosed between the curves y equals x squared plus 7 and y equals 2x squared plus 3. Again, I'm going to challenge you, see if you can do this yourself. Pause the video and have a go. Hint, you're going to need a sketch. Okay, let's do this. So, my sketch. I know what x squared looks like. I know if I add 7, then it's a translation, 7 units in the y direction, so it's going to look a bit like this. That's going to be my y equals x squared plus 7. I know that 2x squared is a stretch in the y direction, so it's going to be sort of steeper. And then I'm adding 3, so it's going to be like this. So it's going to come, I'm going to do it in a different color actually. It's going to look a bit like this. Okay, so I've got my 3, and I've got my 7, and then it's going to intersect at 2 points here, and it wants me to find the area enclosed between the curves. So that is going to be this area here in green. Okay, wonder, can you see how we might be doing this? What we are going to do is we're going to need to find out where the curves intersect. Then once we've got that, we can integrate under the red curve to get the whole of this area. We can integrate under the blue curve to get this little bit, and then we can subtract them, and that will give us the green part. Okay, let's do this. So we know we need to solve x squared plus 7 equals 2x squared plus 3. We can minus the x squared, we can minus the 3, we're going to get x squared equals 4, x is going to equal plus and minus 2. That's going to be 2, that's going to be minus 2. So I'm going to do all this I'm going to do the second method that I used before for this. So I know that the area is going to be the integral from 2 to minus 2 of everything under the red curve, x squared plus 7, and then I'm going to minus the integral under the blue curve, 2x squared plus 3. So the safest way, the way I would recommend, would be to work each of these out. I'm just showing you how you might combine it together. You might, it might be a situation where you might be asked to combine it. So we can now write this as, so it's going to be x squared, and then we do a minus 2x squared. So I'm going to get a minus x squared, and I've got 7 minus 3 plus 4. So I've transformed these two integrals into a single integral. I'm now going to integrate, so square bracket, I'm going to add 1 to the power, divide by the new power. This becomes 4x, and I'm integrating between 2 and minus 2. That's going to give me, I'm going to substitute my 2 in, I'm going to get minus 8 over 3 plus 8. And then I'm going to minus, and then this is going to become 8 over 3 minus 8. Okay, I'm going to keep going. I think I can do this all without a calculator. 8 over 3 plus 8 minus 8 over 3 plus 8. That's going to give me 16 minus 16 over 3. 48 over 3 minus 16 over 3, or 32 over 3, 10 and 2/3. Okay, so yeah, okay, you might use a calculator to do it a bit quicker, but we can do the whole thing without. Now, if we had worked out, do you know what I'm going to do? I think it's worth doing. So let's work out this one here. This would have been the whole red area. We've got the answer. We're just sort of doing it the first method now, actually calculating the big area, and then we're going to calculate the smaller area, and we're going to subtract them. So the integral between x squared plus 7 between 2 and minus 2 is going to be a third x cubed plus 7x is going to give me 8 over 3 plus 14 minus 8 over 3 minus 14. Okay, I think I'm just going to use my calculator now. So I get 100 over 3. That is me working out that whole red area. Now we're going to do the blue area. That is my 2x squared plus 3 integral. Okay, that's going to give me x 2x cubed over 3 plus 3x brackets 2 minus 2. Substitutes in. Oh, it's getting a bit messy now. It's going to be 16 over 3 plus 6 minus 16 over 3 minus 6. That should have been an equals there. So that's going to give me 16 over 3. That's going to give me 68 over 3. So that's the blue area. So the total green area is going to be the red area, 100 over 3, minus the blue area, 68 over 3. So area 100 over 3 minus 68 over 3, and that is again going to be 32 over 3. So I know I've spent quite a long time on this, but I just want you to be aware of both kind of ideas. You can calculate areas and subtract them. You can combine integrals in one go and do the whole thing. Being able to do both is important. So when you get this sort of question, just be careful. A sketch is really useful. I mean, you never know, there might be negative parts as well, and then just think, how are you going to combine it? Sometimes you might need to find points of intersection. There's lots of possible things that you could be asked to do. So I've just shown the basic idea, and it's your job now to just practice and make sure you understand this.